That's bizarre.
Oh.
Well, I guess you can just show it that way. Okay, so if you go back to the slide before that, you can
Yeah, there
see.
we go. Well, I'm trying to figure this out.
Yeah, the poor quality water in the sand, you can tell it's not really good water because it's got a low resistivity. If you want fresh, clean water, you've got to have a much higher resistivity. So that's what you're going to see there. It's sand, you know it's sand because it's got a high SP. And B is, yes, it's always going to be an aquitard. When you have low SP, low resistivity, that's going to be shales and clays, and they are not going to be good water producers.
Oh, come on.
Looks like you're just going to, unless you want to go through the whole thing from the beginning, you're just
No,
going
it's
to.
not even going there. So, okay, well, we'll have to get by with this panel on the left, I think, since it's not reacting. Okay. There we go. All right, so remote sensing, kind of like geophysics, in that we need to know what's available. Many different kinds of images are available to us. And how we obtain those images, because that might play into your budget. Where to get the images, and there are a number of agencies that I'll talk about in a minute that provide these images. And what kind of information can we get from our remote sensing images? As we're planning an investigation, what would be the appropriate use? And how do we get the scales of the air photos and work with converting those scales? So these are all things that you'll need to know. Yeah, I know, but that doesn't always work for me, Tom. So, okay, so here we're used to having and looking at black and white stereo paired air photos. And usually they're vertical, but sometimes they can be oblique. And so you might be given a single photo that is oblique that you need to identify what's on it. For the black and white images, you can get a basic analysis. Structures, drainage patterns, landslides if they're big enough, some geomorphology, and so on. You can also measure some distances from the air photos. But because our eyes are hardwired to see color, we can really see a lot more detail if we're looking at color images. Our eyes can only see maybe 20 shades of gray. So these can be used for gross analysis, but not the finer details. And then when we have a air photo that is corrected for scale, so that the scale is the same throughout the image, because of maybe the camera's tilted a little bit or there's some relief. These are called orthophotos, and they're very useful in terms of having that same scale throughout. My mouse is deciding to give up. Okay, and then as we're obtaining these air photos, the airplane is flying in a line and taking images as it goes with an overlap of about 60%. It then turns around, comes back, and it needs a side-to-side overlap, 20 to 40%. And it's this overlap of the images that allows us to see stereo. We want to take the photos at the same time of day, either early in the morning or early in the evening, to get the shadows to appear, because those can help us in our interpretations. But it's not the thing that gives us the ability to see stereo. It's the overlap. Now, sometimes we can work with a suite of images of the same thing. And here we have an image of an area in Napa, California, and nothing really stands out until I get to the false color, and I see this structure right here has the same properties as the river. So we might think that that is a sewage treatment plant, something like that, that's open to the air that has water in it. Now, the color image doesn't give us a whole lot more information in this particular case, but having a suite of images of the same thing can aid in our interpretations. So, false color or color infrared photography is very useful. Our eyes can't see in the infrared. So by using filters, it allows us to capture some of the infrared, particularly where plants are concerned. So here we have a normal color image. This is between Baltimore and Washington, D.C. And the cultural features show up as silver. When we apply the false color, we see that what was green for the plants is now red. And the stronger the red is, the more healthy the plants are. So we can come up with any color scheme that we want. RGB, red, green, blue, is usually the most common color scheme. So we can look at assigning different colors in our end product to show us things in the near infrared. And the thing that's useful about this is that it can see through the haze. So where we have a lot of humidity, like in the East Coast, we can get images that are more distinct and clearer from that. And so this is often used in looking at the health of crops and also soil moisture that's available and whether the soils are saline. I don't know, I think it's my mouse that's not working well, so we'll see. Okay, now high altitude images, either in black and white or color infrared, are flown at 40,000 feet. And because of that, it covers a larger area and it has less detail. So in the black and white image, I really can't get much information from that. The color infrared gives me a little bit more information. This is of Washington, D.C., and you can see the areas here. Here's the mall, and here are some parks and places where we have strong reflections in the infrared, and that can tell us something about the health of the plants. So the main uses of these high altitude images is for forestry, looking on a regional scale to get the health of the forests. Now, there are different sources for these images, and one that you might not think about is the U.S. Department of Agriculture. They have a field office, and they're now the repository for a lot of the images that the USGS took. So the high altitude or National High Altitude Program has the black and white and color images. And then that was replaced by the NAPP. And this was flown or is flown on a regular basis. So these are good for site histories if you need to go back and you're doing a hazardous materials search and you're looking at the site uses through time, this would be a good source of a number of those images. And then the USGS also has an archive. They call it Earth Explorer. And in addition to the air photos that they have some radar images and some Landsat and spot images. So you can go there and look through what they might have. But these are the two main sources of air photos that we have. Now, we can also use thermal infrared, which is taken at very long wavelengths, and it gives us an idea of the heat that's reflected. Here's a black and white image in Florida, and we have brighter white areas in some of these creeks where we have springs that are emanating at a warmer temperature. So we could use this also for environmental monitoring, where we have discharges of wastewater, and you could use this at night as well. So they couldn't get away with discharging when they're not supposed to. And then it's also useful for geologic mapping. This is an area in Eastern California, and it's mountainous, and it's in the desert. So it's pretty hot in the field season. So by looking at the thermal characteristics of the rock, you could actually map what you're looking at based on the colors that you get. So this would be a great way to start out doing some field work without having to go out in the field. It's also useful for buried karst and these other uses that you see here. I'll talk in a minute where we have the thermal infrared. Yeah, that's why. Let me give you a quick review here.